You ever have one of those brilliant ideas for an app and just wonder, how do you actually make that real? Well, today we're going to pull back the curtain on that whole process. How a simple thought gets transformed into the complex, amazing software we use every single day. So let's jump right in.
So really, how does it happen? How does that little spark of an idea, that wouldn't it be cool if moment, actually turn into a real working app on your phone? Spoiler alert, it's not magic. It's actually a really well-defined, structured process.
You know, the best way to get your head around it is to think about building a house. Seriously. You wouldn't just show up with a pile of wood and start hammering things together, right? Of course not. You'd need a plan. You'd need blueprints. And in the world of software, it's exactly the same idea.
So, the very first step is to figure out what kind of house you even want to build. This is what we can call the wish list phase. Before anyone writes a single line of code, you have to get a deep understanding of what the client, the person who's going to live in this house, actually wants and needs. In software engineering, this wish list has a formal name. It's called the analysis model. And here's the absolute key. It is all about the what. What is this system supposed to do? What problems is it solving for the user? We are not, and I mean not, worried about how it's going to do it yet. That comes way later. This whole model is built from 4 key pieces of information.
First up, you've got scenario-based models. The best way to think about these are as little stories of how people are going to use the software. They capture who is doing what, and more importantly, why. We often call them use cases, and they're basically just narratives that describe what a user is trying to accomplish.
Okay, so take a look at this. This visualizes those stories perfectly. What we're seeing is an airport check-in system. You see the actors, like the tour guide and the passenger, on the outside. And their goals, things like group check-in or security screening, those are the stories, the use cases, on the inside. This one little map tells us exactly who's going to be using our system and what they need to get done.
Next up, we need the plumbing and the electrical plans for our house. And that's pretty much what flow-oriented models are. They couldn't care less about the user stories. What they care about is how information, data, moves through the system. Where does it come from? What happens to it? And where does it go?
And wow, this diagram just lays it all out for an online store. You can see the journey of the data, right? A select item action from the customer sends cart item data right into the shopping cart. Then the checkout process sends item details over to collect payment, which then talks to the credit card company. It's a complete roadmap for the information.
Now, this third piece of our wish list might sound a little familiar, but trust me, the perspective is completely different. This is all about the system's behavior. So, while scenarios focus on the user's story, behavioral models focus on the system's reaction. How does the software itself react when someone clicks a button or an error occurs? It's all about what the system does from the inside out.
And check this out. This sequence diagram is a super simple, perfect example. It's basically a timeline of events. Step 1, the user opens the app. Step 2, the device tries to access the webcam. Step 3, boom, a hardware failure happens. It maps out cause and effect over time, showing exactly how all the different parts talk to each other, one step after another.
And finally, the last piece of the puzzle. If the other models are about actions and flows, this one is about the actual things we're working with. It's our list of materials. You know, what is our house made of? Bricks, windows, doors? In software, these class-based models define those fundamental building blocks. They identify the key objects, like a customer, a product, or a shopping cart, and lay out what they are and how they're all related.
Okay, so we've gathered all this incredible information. We've got our user stories, our data flow maps, the behavioral diagrams, our list of building blocks. The whole wish list is complete. Now comes the most critical part of this whole thing, turning that wish list into a set of technical blueprints that someone can actually build from.
This right here is the big pivot. It's the moment we stop talking about the what and start talking about the how. We take all those abstract user needs and stories from our analysis model and we translate them into a concrete technical plan, the design model. This is what a team of programmers can actually use to build the software. This is the absolute heart of software design.
So if you take one thing away from this, it should be this idea right here. The entire design process is really just about one thing, reducing abstraction. We start way up high in the clouds with the customer's vague idea, and we move down, step by step, getting more and more detailed, more and more technical, until we have a plan so specific it can be turned directly into code.
So what do these technical blueprints actually look like? This is the final output of our design process. And it's not just one single diagram. It's a whole collection of interconnected plans that describe the software from a bunch of different angles.
This output is called a design model, and just like our wish list wasn't one simple list, the blueprint isn't one simple diagram either. It's better to think of it as a hierarchy, a set of 4 layers, starting with the highest level big picture view and drilling all the way down to the tiniest details needed to actually build the thing.
So let's walk through this blueprint, layer by layer. At the very top, you have the architectural design. That's the master floor plan for the entire system, showing how all the big pieces fit together. Then you go down a level to interface design. This details every door and window, how different parts of the software or the user will interact. Then we drill down even further to the component level design. This is the detailed construction plan for each individual room or module. And finally, at the very bottom, is the data/class design. This is our super detailed materials list, specifying exactly what those building blocks we talked about earlier are made of.
Okay, so I know what you might be thinking. Why go through all this trouble? Why all this planning? Why not just jump in and start coding? Well, because just like building a house, having a solid set of blueprints is the foundation for everything that comes next. It's what separates a stable, well-built piece of software from something that's just gonna fall apart.
The single biggest reason for all this work comes down to one word: traceability. Following this structured process ensures that every single feature in the final product can be traced all the way back to a specific customer requirement. Nothing gets forgotten, nothing gets misinterpreted, nothing gets lost in translation.
And you know what? This pyramid shows that idea perfectly. Look at how it starts with customer needs right there at the base. Those needs get translated up into design features, then into system analysis, and all the way up the chain to quality assurance. Every single level is built on and is directly connected to the one below it. This is how you make sure you're actually building the right thing.
And when you put in the work to build on that solid foundation, you get all these amazing benefits. Your software becomes scalable, which means it's easy to grow and add to later. It's maintainable, so fixing bugs isn't a nightmare. You can even reuse parts of it in other projects. It ends up being more secure, and it just flat out performs better. That is the payoff for all that careful planning.
So the next time you're using an app that feels lightning fast, that's just a joy to use, or maybe one that's buggy and constantly crashing, I want you to think about the blueprints. Think about this whole process from wish list to reality and just ask yourself, is the software I'm using built on a solid foundation or a shaky one?